previous video, we took a look at an overview of interfaces and how they apply to Solid. In this video, we're going to do a hands-on example. In my factory method, when I create a vehicle object, let's say that I want to see if it's a low-emission vehicle and therefore applies for a tax credit. So what I can do is make a new interface called low-emission vehicle, and I can apply that only to the vehicles that are indeed low-emission vehicles. Let's see how that works. Very important, note that I'm clicking interface, not class. And note that we have the word interface here, not the word class. So once again, when we think interface, we tend to think it is just a list of methods. It's also a great place to put JavaDoc, so let's do both of those things at once. I'm making my interface method apply tax rebate int amount as a parameter coming in. So this effectively says, okay, let's apply a rebate to this vehicle. Now, one thing about interfaces, since they tend to be method signatures, we don't tend to do open and close curly. Instead, we just have the method signature and then we terminate it with a semicolon. Now, interfaces, because they are often the variable type, is a good place to put JavaDoc. So a lot of times to do JavaDoc above the method, as we see here, and JavaDoc above the interface as well. Provided the JavaDoc is good and explains most cases, then oftentimes we don't need to JavaDoc the class that implements this interface because it's a given that the documentation is already in the interface. So we have our interface now, but how do we actually implement it? Well, with that word implements. Now let's look at our cars. Is Mustang low emission? Probably not. Is Sonic low emission? Maybe, but maybe we say it has to have some kind of hybrid component. So Prius is the most obvious. Now we see that Prius extends vehicle. We've already done that. And we can only extend one class, but we can implement as many interfaces as we want. And we do so simply with the word implements. Now, as soon as I do that, I get a red line. And the reason is, if I implement an interface, I am under contract to provide an implementation for all of the methods in that interface. Or there's a little caveat there where my subclasses could, but let's not worry about that. Let's just think we have to implement the method that I put on that low emission vehicle, which is apply tax rebate. So redline's going to help me out here. I can choose Alt-Enter and then implement methods and OK. Well, now I simply need to handle this somehow, which means I need to account for that tax rebate. Now this is specific to Prius, not all vehicles. So it's best that we put this logic in Prius, not in the superclass vehicle. Simply initialize it to 0, this tax rebate, and then for apply tax rebate, we will assign that amount to tax rebate. So this won't change any of our calculations on the miles per gallon, gallons of gas, so on and so forth, but it does demonstrate a concept that Prius is a vehicle. Prius is a low emission vehicle. And with Liskov substitution from Solid, we know that Prius can be substitutable for either of these, and that a variable of type low emission vehicle can hold an object of type Prius, a variable of type vehicle can hold an object of type Prius, and a variable of type Prius can hold an object of type Prius. So we have a lot of options here. Now, here's the cool part. Let's go back to driver and let's go back to our factory method. Actually, right under this, let's make a new method. We'll call it apply for tax credit. We're going to define a parameter in just one moment. And what should that parameter be? Well, it's something where I want to be able to invoke this method, apply tax rebate, and say pass in 200 or something like that. So what could qualify for that? Well, could we do vehicle? No, can't do vehicle because vehicle doesn't have that apply tax credit. Could we do Prius? Okay, there we go. There's our apply tax rebate. But you see, this isn't very dynamic because there are a lot of vehicles that apply for tax rebate that are not Priuses. So we'd have to make a method for each one of those vehicles, you see, and that'd be really inefficient. But let's consider something else we can do. Remember, the interface can be a variable type. So let's just say low emission vehicle. And now, lev.apply tax rebate, boom, it works. Now, let's look at something interesting here. What methods can we call on low emission vehicle? Can we call set gallons of gas? No, we can't call any setters. Can we call the getters? No, not except for get class, which we inherit from java.lang.object. The only method we can invoke on this, aside from those inherited from java.lang.object, is apply tax rebate. And why is that? Well, remember polymorphism. Variable type tells us what methods we're allowed to call. object type tells us what's going to happen when we call those methods. In this case, the variable type is the interface, and the interface only has one method defined on it, and it's apply tax rebate. So if the variable type is that interface, that's the only method we're allowed to call. Of course, aside from anything that's inherited as well. But nonetheless, that's part of the value of interfaces, is not just that it tells you that these methods are the ones that you're allowed to call, but also that it hides methods that are not important. So when we're dealing with low emission vehicle, we're dealing only with those methods that we find in low emission vehicle. Now let's take a look down here when we create our Prius. This one's a little bit tricky. Can we pass the Prius in? Not as we're doing it here, because we're storing it in a variable of type vehicle, and vehicle is not necessarily a low emission vehicle. So we have to do this in two steps. We have to declare it as a Prius first. Prius equals new Prius. Now can we pass the Prius in? Oh, yeah, look at that. That works. Awesome. Okay. But we still need to assign something to this vehicle variable, which is getting returned down here. Easy enough. We simply assign the Prius object to the vehicle, because remember Liskov substitution, the subtype can be substitutable for the supertype. So we started as a Prius. We pass that Prius down to our apply for tax credit, and then when we're done, we just simply take that Prius and assign it to vehicle and return the vehicle. Now, would the same thing work for a Mustang? Let's try. So what I have right now is essentially the same as I had before. I'm just creating a new temporary Mustang type. And we find it does not work. And why not? A required type low emission vehicle provided Mustang. So a Mustang is not a low emission vehicle. Now, a Prius is a low emission vehicle. But you see that this interface essentially becomes a gatekeeper, and it will only let in those variables that implement that interface, like Prius. Now, we could have some fun and do it with Sonic as well, but we get the idea here that only the Prius, when it's looking as a Prius, can be passed into this method as it exists right now, because a Prius is a low-emission vehicle. But not every vehicle is a low-emission vehicle. So, I'm going, just to test out our whole theory here, I'm going to add that to our toString and then just do a quick demonstration. And sure enough, you see that tax credit of 100 was applied, as we can see in the output. So in this video, we've seen a demonstration of interfaces and how it can be used not only as a variable type, but as a parameter type for a method. And then we can only pass in variables where the type, the class of that variable or whatever, implements that interface. So interfaces, absolutely central to polymorphism. And as we get into advanced topics in future classes, future lectures around things like Spring Boot and API development, enterprise application development, or COIN in programming mobile devices or Android programming, we'll see that this concept of interfaces is absolutely fundamental to programming. It's also fundamental to things like callbacks, where you shoot off some asynchronous task, and when it comes back, it wants to call you back and say, okay, here's what I've received. It is also absolutely fundamental to design patterns. And design patterns, to me, is really what separates someone who writes code from somebody who really thinks about architecture in a very clean and durable way. So this is the start of a whole new chapter in your programming career, and I can't wait to talk more about it. I hope you enjoyed this video, and I look forward to reading your comments. Thank you.